All right, any questions on the homework? Vertex form, graph from vertex form, using 3 points in transformations, and then turning things from standard form into vertex form using complete the square. Complete the square is usually where we make our mistakes. We forget. I'll do one example and just remind you where the main mistake is. All right, no questions? All right, make sure homework gets turned in. And we have a full day of stuff today, but it's all basically on the same stuff. But it is a bunch of stuff. And remember, I still owe you that proof of why that formula is true. Said we weren't going to use it yesterday, but we will today. All right. Test on Tuesday. And then, hey, look, fall break. Homework. How would you know just by looking at it? Well, it there's this amount of problems, and I'm not going to give you 50 problems and it not be quick type thing. That's not 50 problems, by the way. Good? No. All right, very quick review of what we did yesterday. So last class, we started off with this is the definition of a quadratic function. This is called standard form, by the way. We basically made a note that parabolas have a couple main parts. It's got its vertex. It does have an axis of symmetry. We'll use this today. We didn't use that yesterday. Axis of symmetry that goes through the vertex. And then potentially it has x-intercepts, but it will always have at least one y-intercept. All right, can't have more than one, but it will have one y-intercept. And then remember, for x-intercepts, it might have 0, 1, or 2 x-intercepts. We'll use that today as well, too. Yes, I took attendance. We talked about the effect of A on the quadratic. And remember, if A is greater than 0, that means it's smiley face concave up, which means it has a minimum, kind of a paradox or irony. If A is negative, then it has a maximum, and it's concave down. And then lastly, if I let A be greater than 1, it yanks it vertically, stretches it vertically. And if A is between 0 and 1, it compresses it. Now, remember, the absolute value takes into account that it could be concave up or concave down. All right. Then we started to do, after a little bit of magic, we got to the definition of the vertex form. And I said yesterday we weren't going to write this formula down, but today we will be using this formula right here to do something. So don't write down yet. We'll get to it. But if it's in vertex form, it looks like this. You can identify it because it has parentheses and a square. On the inside, it's the opposite of h. That's your x value of your vertex. And on the outside, k, not negative or opposite, is the y value of your vertex. We talked about in terms of transformations, on the outside is what stretches it vertically, so that affects the y values. We talked about the h on the inside moves it left and right, and it's the opposite of what you think. So minus h actually moves it to the right, and the k on the outside moves it up and down. All right, so skill number 1 was graphed it by hand. I'll slow down now. This is what your homework was. They're going to give you a function. It's going to be a quadratic in vertex form, and you have to graph this by hand. Step number 1 is you look at what those transformations are. So from inside out, inside the parentheses to outside, the first thing you see is a +2. So this is moving it to the left, two units to the left. So in terms of the x values, that would actually mean subtract 2 from the x values. Next, you have a 2 on the outside. That affects the y values. So that's the y values multiplied by 2. It's a vertical stretch. And lastly, the final thing is the -3. The -3 takes the entire parabola and shifts it down 3 units. In terms of math, the first one, the x shift left 2, that means subtract 2. The y stretch is multiplied by 2, and the y shift down is subtract 3. So we're going to apply all of that to the parent function. So the parent function, remember we said, hey, here's 5 points. There's plenty more points, but these are the 5 common ones. We said we don't necessarily need all 5. We can get by with 3 as long as one of those points is the vertex. So we decided to, for instance, 2, 4 is on the parent function right here. So if we apply these shifts to it, x is shifted left 2, so that means we need to subtract 2 from the x value, so that 2 and this 0.24 turns into a 0, 4. The y is stretched 2, so we take the 4, we multiply by 2, that gives me 8. And lastly, shift down 3, that would be 8 minus 3, which is 5. So that's just that one point right there on the parent function. That's its transformation. So in order to graph it, we decided to do it to 3 points, and the 3 points we picked were the negative 2, 4, 2, 4, and 0, 0. Okay, so here's a real one. I'll do this by hand. This is a more challenging one because of the fraction here. So let's see, from inside out, it's still this. We're going to subtract 2 from the x values. We're going to not multiply by 3. We're going to divide by 3 or multiply by 1/3. And lastly, we're going to take the y values and add 3 to everything. So we take the 3 points of our parent function, right? And we apply the transformation. Now notice, if you have to divide by 3, you can divide anything by 3. It's just that we don't want to divide like 4 by 3. We're picking a number that's nice and friendly. So my suggestion yesterday was look at the denominator of that 1/3, square that, and that gives you your points, both positive and negative. So negative 3, 9 and 3, 9, that's a point on the parent function. We're going to choose that rather than negative 2, 4, 2, 4 because we don't divide 4 by 3. 9 is easily divisible by 3. And then we apply the transformations. So we immediately get the vertex. The vertex is going to be at negative 2, 3. So I don't have to do any work for that one. But the other two, I got to do these 3 transformations. So shifting left 2 means subtract 2. So that minus 3 turns into minus 5, and that 3 turns into a 1. And then I do the transformations to the y. I'm going to divide by 3 and then add 3. So divide 9 by 3, we get 3. Add 3, we get 6. And the cool thing about that is that both of the points, since they're symmetrical, you only have to do it for 1. So both of them wind up with a y value of 6. 3 points makes this parabola as long as one of them is the vertex, and it was. So there we go. Now, if you want a more accurate one, you'd have to apply it to other points. Let's see, what's another possibility that's divisible by 3? 6, so 36, right? 36 is divisible by 3, so that would be 6 squared. So we would get negative 6, 36, and 6, 36. But you notice the problem with that is, now how do I graph that on a little tiny graph? Okay. Lastly, what happens if it's not in vertex form? We do complete the square. The process of complete the square is step number 1, put parentheses around the first 2 terms, the x squared and the x. Factor out whatever is attached to the x squared. In this case, it was a 3. The problem is, and I gave you nice friendly ones here. The problem is that if the second number, the number that's the coefficient attached to the x is not divisible by 3, you get an ugly fraction that you have to do complete the square. It will still work. It will just be ugly looking. Okay, we make our new c value. So that's the red number divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to the inside of the parentheses. But I just added 9, but it's not really 9. It's 9 times 3, because 3 is on the outside. So I really just added 27. So in order to balance it out, I have to subtract 27. Then I factor this. What 2 numbers multiply to 9, add to 6? 3. So x plus 3 squared. And then magic, that's the magic, right? It turned into vertex form. For homework, they asked you to take that and graph it, right? I'm not dividing, I'm multiplying by 3, so I can use my standard points, right? Negative 2, 4, 0, 0, 2, 4. The vertex is at negative 3, negative 2. And then let's see, I have to what? Add 3 or subtract 3? It's always going to be the opposite. I have to subtract 3 from the x value. That's going to give me negative 5 and negative 1. And then I need to take the y values, multiply by 3, and then subtract 2. 4 times 3 is 12. Subtract 2 is 10. So I get those 2 values. So once you do, like I said, you know, we only did a couple of these in class, but once you do 3 or 4 of them in homework, the process is pretty darn quick. Questions on that? That's everything we did yesterday. All right, so here comes the new stuff. Remember, to graph things by hand, we basically so far have 2 methods. Method number 1.
Calculator.
That's okay. So we have more than one. So without a calculator, because it does say by hand, Jack.
Oh, darn. I was looking at
Table of pain, crazy,
Oh,
huge
yeah.
table of pain. You don't even know if you're going to get it right because you don't know where the vertex is. Right? Obviously, it's in vertex form. You could do a table of pain, but the other method is just as quick. The second method is what we just did right there. If it's in vertex form, we apply the transformation. Turns out.
There's a method 3.
There's a method 3, and that's what today's class is on. Oh, by the way, if it's not in vertex form, you can always you can do complete the square and put it out in vertex form. Turns out there is a method 3, and that's what today's class is on. So here we go. So let's go back to this right here. And yesterday we did not cover this thing right here where it says where h is equal to negative b over 2a and k is equal to 4ac minus b squared over 4a. So write this part down as well as the vertex form. Because today we're going to use this method. I got to prove where this comes from first, but then we'll use this. It's a competing method. It's probably just as much work as doing transformations. Why do I need 3 methods if the second method was perfectly fine? Right, valid point. The book shows us 3 different methods, so we're going to see all three methods. Table of pain, because you're all about pain. So that's what we're going to concentrate on. You know, if you do a table of pain and you found the vertex, it works fine. Do these formulas look any familiar to you at all? Like, do you recognize anything?
You did. I saw
I feel like I do, but I don't know why.
Yeah, it seems somewhat familiar. Well, it's not happenstance, right? It's for a reason that somewhat looks familiar to you. Yeah, that's where it comes from. And that'll be the proof, by the way. All right, everybody good? All right, so if you know the vertex, because it's in vertex form, then it turns out you know the axis of symmetry as well, too. Think about it. If you know the vertex, this black dotted line goes through the vertex. All vertical lines are of the form x equals. So basically, it's the x value of the vertex. So you know the axis of symmetry because you know the vertex if it's in vertex form. It's just the x value of the vertex. That is the axis of symmetry. All right, cool. If you know the axis of symmetry, well, then you know that any point you find on the left side or the right side has a partner on the opposite side. So for instance, this x-intercept, if it's 3 units away from the axis of symmetry, on the other side, there's another point that's 3 units away from the axis of symmetry, which is quite convenient. If you find the y-intercept, and the y-intercept is 1 unit away from the axis of symmetry, then you know it's got a partner 1 unit away on the right side of the axis of symmetry. Do you get the point there I'm making?
Yeah.
Okay, cool. So if we can find the x-intercepts and the y-intercepts and the vertex, well, then we can get some other points for free with no work involved, right? You do have to find the x and the y-intercepts, but we already know how to do that as well, too, right? So method number 3 is going to be, if it's in vertex form, we're going to graph it using the vertex and the intercepts. All right, so to do this, first off, you got to identify the vertex, which is convenient if it's in vertex form. Step number 2, it could be step number 3. It doesn't matter which one you find first. You're going to find the intercept. So y-intercept and then the x-intercepts, if possible. Why do I say if possible? It might not have any, right? And then lastly, you're going to get some points for free, and those are the ones that come along with the fact that the axis of symmetry breaks it into half, right, or mirror image of itself. All right. So step number 1, find the vertex. Stupid simple if it's a vertex form. Jace? Vertex of the first one,
-2, 3.
second one,
Tell me?
Yeah.
-2, -3.
and the last one.
3, -2.
All right, can you do what Jace did?
Yeah.
All right, that's why there's a bunch for homework, because the first couple questions are like, what's the vertex? It's gonna be in vertex form, there's nothing challenging there. Okay, you just need to remember that the inside is your X value, the outside is your Y value, and the inside will always be the opposite. All right, did I insult your intelligence enough? Cool. All right, super easy, right? There's always a but. The but here is, what if it's not in vertex form, right? Then we have to
Complete the square.
put it in vertex form. This is the one that we just did, right? So I'll just flip through this real quick. So just like yesterday, if it's in standard form, you got to put it in vertex form. Or we had this formula right here. Notice on one side of the formula it says H and K. On the other side it says A, B, C. And that's kind of convenient because guess what? When it's in standard form, it's an A, B, and C. So that makes it convenient, which is why I had you write down that formula. So if it's in standard form, turns out we don't need to put it into vertex form. We can simply use this formula, which makes our life a little bit easier. This is why I say this is a competing technique. So I'm going to recommend from now on that if it's in standard form, this is the method that you use. Why do complete the square if we have another method that doesn't require us to put it into vertex form? Unless it specifically says put this in vertex form, then you don't need to do it. You can use this formula right here for your H and your K. All right. So remember, in standard form, number of the coefficient to the x squared is a, the coefficient to the x is b, and the constant is the constant. That's your a, b, and c. Okay. All right. I got to prove this. I can't just make that claim. So here's the quick proof. This one is in standard form. Yes.
Yeah.
We know that if I can find the vertex, right? If it's in vertex form, the vertex is HK, right? If it's in vertex form, is that in vertex form? So let's put that in vertex form. We know the process. How do you put that in vertex form?
Complete the square.
We got to do complete the square on this ugly mess right here. Okay, so parentheses around the first and second. Then what?
Factor out A.
Factor out A, so divide both sides by A. Now look what I did right there to this. If you divide B by A, you get B over A, right?
Yeah.
Okay, so now do complete the square on this. Ooh, this is where it gets challenging. What are we supposed to do?
Then take B over A.
I got to
Divided by 2.
divide it by 2. Well, that would put a 2 where? On the bottom.
And then you put
On the bottom, right?
Yeah.
So I get B over 2A, and then I got to square that. So B over 2A squared would be B over 2A squared would be
B squared over 4A squared.
B squared over 4A squared, right? So if I take that, I divided it by 2, right? And then square it, I get B squared over 4A squared, yeah? So that's what I'm going to, that's my new C value. That's what I'm going to add right here. Okay, but if you add, now I got to subtract something. There comes the tricky question. What are you going to subtract?
B squared over 4A squared. No, A times B squared.
So what would you subtract?
Uh,
She's saying, I got to take this thing right here and multiply it by A, and that's what I'm going to subtract. So do that.
AB squared over 4A squared, except you can
A's would
so
cancel.
it's B squared over 4A.
So it's B squared minus 4A, right? That's what I'm going to subtract from that side. Cool. All right. To factor this right here, what two numbers will, or you could just remember it's this, the square root of this. What's the square root of this? Whole thing, square root of this.
B over 2A.
B over 2A, right? So it would be X plus B over 2A squared. Well, that's a big hot mess over here. Any suggestions?
Try.
Yeah.
Any suggestions? Don't overthink it.
Pretend like it's not there.
Pretend like it's not there. No, that's what a dog would do.
I do.
Turn their head like it's not there.
I got my dog.
Just it's fraction, common denominators, right? What's common denominator?
Oh, it's
What's the common denominator?
4A.
4A. So I got to multiply C times 4A over 4A. So I would get 4AC minus B squared all over 4A. Does that look familiar? Why did I make it red?
Because
That's your H and K. That's where the formula comes from. Now remember, why is this one minus? Because remember, it's always the opposite of this. So there's your proof of why that that formula actually works. Okay, so now we proved that we can use it. Okay, cool. So that's what we're going to use. Now remember what I said. If they give it to you in vertex form and your whole idea is to graph it, you would not use this technique, right? This is, they give it to you in standard form and they ask you to graph it. So I don't want to do a table of pain, but I can find the vertex very easily with this method right here. Because this is in terms of A, B, and C, right? Secondly, this is big honking complicated right here. It turns out, remember, for any function, if you find the x value, to find the y value, you just plug it back into the function. You can use this, right? You're not going to see me do it, but you could use this to find the k. The easier way to find the k is, once you find out what h is, you got to find out what h is, just plug it back into the function, and that will always spit out the y value. So you're not going to see me use this formula right here. You're only going to see me use the h formula. And it's also easier to remember because it's negative b over 2a. All right. So we're going to calculate h, right? It's really just the x value of the vertex. And then we're going to plug it back into the function to figure out the y. And if you don't like that, you can use this to find the k value as well, right? All right, so let me show you how that works. Let's find the vertex, right? Anybody remember what the vertex was for this one? When we solved it? When we put it in vertex form? No? Okay, well, then let's find the vertex. Find the vertex, we find the x value. What's the formula for the x value? You just wrote it down. What's the formula for the x value? Negative b over 2a. So what's b there?
In 1,
B is 18, right? Remember, there's the formula right there. So I just need A, B, and C. So B is, in fact, I don't even need C for the H formula. I just need B and A. B is 18 and A is? So it's negative B over 2A. 2A's would be 6. So it'd be 18 over negative 6, right? Or negative 18 over 6, however you want to say that, which is?
That's just -3.
That's -3. For those who remember, that's what we got in vertex form. And I said we could use this formula for k, or we can take the -3,
and plug it back
just
in.
plug it back in. -3 squared
9,
times 3.
7.
Ooh, 18 times 3, it's -3. 54, so minus 54 plus 25. So after I do all that, I'm just plugging that into that value right there. So that was 27 minus 54 plus 25, 27 and 25. 27, 25?
No,
50.
52 minus 54,
-2.
and you're done. So there's your H and K, there's your vertex, which matches what we got before, for those of you that are paying attention. Okay, cool. That is the recommended way to do this, rather than complete the square and then do all your transformations. Hey, look, we already found the vertex right there. Cool. You see that again? Sure, let's do one. All right, new one. Find the vertex. Tonight for homework, they're going to give it to you in standard form, find the vertex. You could do complete the square, or you can simply use this formula. Negative b over 2a. So if I do negative b over 2a, ABC, I don't really need the c value, I just need a and b. So what's negative b over 2a?
-6
Over
2a. Oh wait, no, over -6.
which is uno, which is 1. And you can do that pretty quickly, almost in your head. What do we do with the 1?
plug it in.
We plug it back in. 1 squared times -3. -3 plus 6 plus 1. -3 plus 6. 3 plus 1 is 4. That was quick. You just found the vertex that quick. No complete the square necessary. Does require you to remember the formula though, thank God. You can bring 2 sheets of paper into all tests. Because this is a forgettable thing. All right, cool. We found the vertex. Want to see it again or you got it? Abby speaks for the class? Okay.
Yes.
All right. So remember, using our previous knowledge about mins and max, what has a min, what has a max? What has a min, what has a max?
Concave
If
down
it has-
has a
Concave down has a,
max, concave up has a min.
so is this a min or a max?
No, min.
I heard both answers.
Wait.
First off, is this concave down or concave up? How do you know it's concave down?
Negative.
Because of the -3, therefore it has a max, and where does the max always occur? At the vertex. And what is the max, therefore? That's the vertex. What is the max? It happens at the vertex, so what is the max? In other words, what's the highest number it goes to? It goes to 4. It's always the y value. The y value will be the min or the max. Where it occurs is at the x value. What it is the y value. Okay? Does that make sense?
Yeah.
Okay, so now we added another question that we can ask. Find the axis of symmetry in the min max. Okay, so where's the axis of symmetry? For any parabola, where does the axis of symmetry occur? It occurs at the vertex, which is the x value of the vertex. So therefore, as Jack just said, the axis of symmetry is at x is equal to 1. Remember, it always happens at the vertex and the x value. Okay, so cool. Easy to do. So the axis of symmetry is at 1, or x equals 1. And the min and the max, we decided this was going to be a max, and the max is at 4. All right, cool. Easy, easy, easy. All right. Yay for us. And this was just I'm just showing the slide again to remind you of concave up has a min and concave down has a max. Okay. So all of that just simply to figure out the max was 4. Got it? Is the next thing. So one more time. Find the vertex, the axis of symmetry, and min or max. Standard form. If it's in vertex form, you can answer all the questions immediately, right? But it's not. It's in standard form. So the easiest way to find the vertex is not to do complete the square. It's to use this formula right here. So h is negative b over 2a. So what is, I don't even need the c value for this, although I keep saying a, b, and c. Okay, so what's the vertex? So we need to do negative b, so that would be negative 4. So that's 4 over 2 times 2, which is 4. So we get 4 over 4, which is 1 again. So we love our 1s. Okay. Now I take this to find the y value or the k value. I take it, throw it back into the formula. 1 squared times 2. 2 minus 4.
Yeah.
Negative 2 plus 1. -1. Okay, cool. Yay, we just found our vertex. And from that, we now know our axis of symmetry, our min max, if we look at the a value. Concave up, concave down. Concave up, which means it has a min. So the axis of symmetry is at?
Axis of symmetry is at 1.
Axis of symmetry at 1, and the minimum at -1. I mean, there you go. Really quickly done. Cool? All right. Where were we at? Remember, this was method number 3 of, hey, we can graph this thing, right? So method number 3, the third method to graph is we find the vertex. We just did that a bunch of times. We find the y-intercepts. We find the x-intercepts if possible. And then we graph using our friend rule. And our friend rule says, if you find one side of the axis of symmetry, you can find the other side and you get it for free. All right. Way back in Algebra 1, this is why this formula seems very familiar, right? This is the quadratic formula, which solves for any quadratic, factorable or not factorable. Do you remember what this thing inside the square root was called? Starts with a D. The thing inside the square root, b squared minus 4ac.
Yeah, I remember.
It was called the discriminant.
Oh, yeah.
And when you discriminate against someone, which is a bad thing,
Racist.
right? You're judging them based upon their characteristics. You're making a judgment call upon some arbitrary characteristic. That's when you discriminate, right? We are going to judge our parabolas based upon its discriminant. And the discriminant tells us, do you remember? The b squared minus 4ac. It tells us how many solutions there are. It tells us whether there's no solutions, one solution, or two solutions. Remember how that works? If b squared minus 4ac is negative,
Then.
can you take the square root of a negative number?
Then that one's the noun.
Then this one would be no solution. If b squared minus 4a squared equals 0, well, square root of 0. So what's plus or minus 0? How many answers are there? one solution, and if b squared minus 4ac is greater than 0, two solutions, right? So this is how you figure it out using the discriminant, right? And so here's a pictograph of that right here. So I've got two x-intercepts, I have no x-intercepts, the orange one and the brown one, or whatever color that is, I get one, right? Cool. Guess why they used a triangle there? What did I call this thing in red?
The discriminant.
Why is there a triangle right there?
That's the discriminant.
Because it ain't a triangle. Guess what it is? It's a letter.
Oh, it's Greek.
It's Greek, and that's the letter D. Now, math people want to sound really smart and like, oh, I can use Greek letters, right? It could easily put the letter D and then everybody would get it immediately, right? Like, why is there a triangle right there? Because it's the letter D. If the discriminant is greater than 0, you get two solutions. If the discriminant is less than 0, you get no solution. If the discriminant is equal to 0, you get one solution. Okay, cool. So in terms of intercepts, right, all quadratics have to have one y-intercept. So you're always, and there'll only be one, right? You're going to find a y-intercept. But for x-intercepts, 0, 1, or 2, right? Okay, so let's use all that. So it says graph the function using the vertex, the axis of symmetry, and the intercepts. Okay. All right. So is it in vertex form? Is it in vertex form?
No.
If it's in vertex form, don't use this technique, right? Use the other technique, technique number 2. But if it's in standard form, don't turn it into vertex form. Use this technique. All right. So our first thing is we're going to find the vertex. So same process before, right? A, B, C, right? First step is we find the x value of the vertex, negative b over 2a. You guys are old pros at this, so that's going to give us
3. No, -3.
negative 3, right? 6 over 2, and it's negative 6 over 2, so that would give you negative 3. Now we throw negative 3 back in, negative 3 squared. 9 minus 18. So 9 minus 18 plus 8, negative 1. So you can find that vertex like really quick. So I find my vertex. That's your first step. Therefore, we now know the axis of symmetry. The axis of symmetry is at negative 3. So that splits our parabola. Concave up, concave down, concave up. So it has a minimum. I don't need to find the minimum, right? We're going to use that. So the axis of symmetry is x equals negative 3. Now we find the intercepts. Doesn't matter the order that you do this in. To find the y-intercept, we let x be 0. Can you see the magic? If you let x be 0, guess what immediately happens? You get 8. So just like y equals mx plus b, the y-intercept, it works the same thing for quadratics. The constant is always the y-intercept. So guess how much work there is for that?
0.
0 work. It's just the constant, right? So the y-intercept is 8. I showed you the work there, but it's not even necessary. So we're like speeding through this process really quickly. Now we just got to find the x-intercepts. That's where the work is involved. So for the x-intercepts, it's either factorable or unfactorable, all right? It either has 0 solutions, 1 solutions, or 2 solutions, right? Sometimes you can just look at it and say, oh, I can see from the start it's factorable. But other times, maybe you want to throw it into the discriminant to see how many answers you get. So for the x-intercepts, we have to solve this one right here. First off, is it factorable? Are there two numbers multiplied to 8 that add to 6? 4 and 2. So therefore, the solution is
-4.
-4 and -2. Remember, we set each one equal to 0 and solve, right? Okay, so here's your two x-intercepts. So how many points do we have now? We have the vertex, and now we have 2 points. What are the 2 points? This is the x-intercepts. -4, 0, and -2, 0. So now I have 3 total points, right? Cool. So here's your 3 total points, and then we have the y-intercept, but guess what you get for free? See this one blue dot just hanging out all by itself?
It means there's another one on the other side.
So you simply count over to the axis of symmetry, 1, 2, 3, and then you go 1, 2, 3, and now you have 5 dots, right? So this technique actually gets us a bit more information. The previous one, we were only getting 3 points. Now we're getting 5 points with basically the same amount of work. This may look like a lot of work, but come on, you guys did have this work in your head. Cool? All right, we're gonna do 3 examples, right? Or maybe 2 until you say I've got this. All right, so here we go. Concave up, concave down, down. Okay, cool. Vertex.
3, 4.
So that would be 6 over -2, right? So that would give us a -3. Wait,
Well,
oh, it was negative, sorry, the 2 negatives cancel. All right, so 3. 3 squared with a negative in front of it would be -9, right? Plus,
18.
which is 9, minus 5, which is 4. Okay, so we get 3, 4. Cool. Secondly, we get for free, we get the y-intercept is -5. Axis symmetry is x is equal to 3. Y-intercept is, I'm not doing that work. It's just the -5. It's always constant. Now we just simply need to find the x-intercepts. Okay, so for the x-intercepts, this one's more challenging, right? Because we got this negative in front, right? So the question is it factorable, right? Is it factorable? We can't ask ourselves the easy one because we have something in front of this. So we have to do it the old-fashioned way. What 2 numbers multiplied together is -1. So the only way that happens is a -1 times a +1. I'm writing the 2 binomials. So I'm writing like x plus 3 times x minus 4, right? And then we're going to do the multiplication to figure out what we get. That's what I'm doing right here. This is how real people factor quadratics that are ugly. What 2 numbers multiply to -5? -5 and 1 or 1 and -5. So pick one.
-1 and 5.
So I want to write -1 and a +5, right? This really represents x and x. Multiply,
-5x.
multiply.
-x.
So that would be -6x, and that's a +6x. So maybe the signs are flipped.
Yeah.
That's going to give me
5.
5x, and that's going to give me, and those do in fact add up. So there's its factor. So it factors to that and to that. I'm going to show you that method, this entire year. Like nobody does the, just to think about it type thing. All right, so that one is factorable, right? So we got a 1 and a 5. Yes?
Yes.
Cool. What are the 2 points?
Wait.
Once you solve it.
1, 2, 5, 6.
What's the problem?
Where'd the negative sign go?
There's an alternate technique of how to do this one. So I was showing you that one. So we got, what did we get? -x. I
Well,
forget what.
the other
Plus 1.
way is to factor out the -1.
Right, so I'm showing this technique first. What did I say the answer was? -x
+1.
+1 and x -5? Yeah.
Yeah.
All right, so set each one of these equal to 0. Guess what you get?
That.
Yeah, but the way
Well,
you
you like this
factored
one
it-
better?
The way you factored it is not.
Do you like this better?
I think.
Guess what I did here?
I'm just confused for no reason,
Well,
probably.
going back a
Oh,
step,
wait, never mind. We're
guess
good
what I
now.
did?
I got it.
But what did I do?
You factored out the negative.
I factored out a -1, and what allows me to do that because it equals 0.
Yeah.
I just want you to remember that what I showed you over here is how you factor a quadratic where a doesn't equal 1.
I got it.
But when you set it equal to 0, you're allowed to do anything in algebra as long as you do it to both sides, so we can multiply both sides by -1. Doesn't work when this would have been a -3x.
I get it.
All I'm doing is multiply both sides by -1, and then it factors really nicely. Still get the same answer, right?
Yeah.
X is 1 and x is 5, and then when you solve that. Okay, what are my 2 points I get from that? Okay, so if we graph those 4 points now, the 2 x-intercepts, the 1 y-intercept, and the vertex, we get this. And then for free, 1, 2, 3, it just happens the same number, 1, 2. It won't always be 3, but in that case it was. So for 3, I get that point, and there you go. Make sense?
Mhm.
Are any of these challenging? The answer is no, they're not that challenging. You want to do this one or the next one? Which one looks more challenging? The next one looks more challenging, all right. We'll do the next one. Okay. Here we go. Ready? Now what? we gotta
Start
find the
with
vertex. All right, so where's the vertex? Negative b over 2a. So negative b would be negative 1, and divided by 2a's would be ugliness, which gives us, what's the ugliness here? Do negative b over 2a, go.
That's -1 over.
It's a fraction, right? It's going to be ugly. It's a fraction. So inevitably, you're going to get to some fractions. Don't panic. Okay, what do we got to do with this? We have to square it, multiply by 2. So what's that squared? 1/16 times 2, which is 1/8. So scratch work. So we're going to get 1/8. Minus a quarter plus 1. Common denominator? So that would be 2/8 and 8/8. So what are you going to get? Okay.
Yeah.
Yuck. Ugliness. 7/8. Okay. All right. Well, that's the vertex. It's just ugly, right? Luckily, that's all we got to do with the vertex. We just have to write the vertex. That's not the y-intercept. That's not the x-intercept. By the way, the y-intercept is at
1.
It's at 1. All right, that's nice. Axis of symmetry is at -1/4. The y-intercept is at 1. Once again, I'm showing the word, but that you get that for free. X-intercept. All right, here we go. Factoring. All right. What two numbers multiply to that?
1 and 2.
So it's either 1 and 2 or 2 and 1, right? That's the only possibility. What two numbers multiply to that? 1 and 1. Right? Cross
2.
plus
1.
is,
3.
and that's 1. Right? Is there another way of getting a positive 1?
Yeah.
If both are negative. Okay, that's going to give me, and that's going to give me,
-2.
that doesn't add to 1. So is it factorable? Is there any other possible combination? Well, maybe these are negative as well too. Right? Because -1 times -2 is +2. Okay, how about now? Multiply.
1.
Multiply.
2.
We still don't get to 1. So have we exhausted all the possibilities? So we've decided it's not factorable. I didn't say stop right there. It's just not factorable. So what do we have to do if it's not factorable?
Try about it.
Cry,
Yeah.
right? Well, first of all, we can see if there's even an answer, right? Using the
Discriminant.
discriminant. We know it's not factorable, but maybe it has an answer using a quadratic formula. So we're going to figure out how many answers it has. All right, go. B squared minus 4ac. Can't talk. B squared would be 1 minus 4 times a.
8.
8. -8.
So we have what? 1 minus 8, and we're going to get a negative answer, right? So we can tell from that right now we're going to get a negative answer. So therefore, it doesn't have any solution. So therefore, we never even should have considered it. So the big question is always, if A is equal to 1, you can tell whether it's factorable just by looking at it. But if A doesn't equal 1, some people, I'm not necessarily like, this one was easy to see if it's factorable or unfactorable.
It was concave up and we had the vertex.
If it's concave up and it's vertex and the
Vertex is
the y-intercept is 1 though. So it still could be below and have answers. That's not the x-intercept, that's the y-intercept.
well, but we have the vertex.
Oh, I see what you're saying. Yeah. So if the vertex is, the y value is positive, right? Meaning it's above, right? And it's concave up. Yeah, I agree. You could have figured that one out. Yeah, sure. So all we got out of it was the vertex. So the question is, where am I getting these other points from? Here's the sad news. Table of pain. But here's the deal, right? As soon as you see the vertex, don't make your life challenging like I did. Take better points. If the vertex is at negative a quarter 7/8, what number should I have probably picked to make my life easier?
Like 8.
Four.
Or
The x value is negative a quarter. I just need a point to the left and to the right. Pick easier points.
1 and -1.
1 and -1 would have been better choices, right? So if I pick 1 and -1, where you can tell that 1, here's the graph, winds up here, and -1 winds up here, that would have given me 2 points that I could equally have gotten the other 2 points by doing that.
Yeah.
Does that make sense?
Yeah.
Okay. So that can occur and it will occur tonight for homework as well too. Does anybody feel like they're lost? Okay. Well, there was my 1 and -1 answers for that. All right, cool. Last idea is this. Can you do the reverse of everything we've done so far?
Yeah.
So reverse would mean, what am I giving you?
graph.
I'm going to give you the graph and you're going to come up with, that sounds crazy. You've never done this before. We've done it with linear equations. I give you the graph, you write the equation of it. Now I'm going to give you the parabola, the graph of it, and you got to come up with the equation. So it turns out this is somewhat of a parlor trick. You know what a parlor trick is?
Something you do.
Victorian area, right? You know, people would, there's no iPads or televisions or radios. So people actually had to hang out with each other and look at each other and talk. And so what did people do?
Make a shield.
They went to the parlor, which is the hangout room in your house, and they sat around and they
Ate ice cream.
performed tricks, ate ice cream. I don't know if they did the ice cream part, but
Ice cream.
like they would hang out with each other. So a parlor trick is a trick done in the parlor, and it's obviously a trick. So here's a trick, right? They have to, in order for this to work, they can't just give you any picture of a parabola and you come up with it. They actually have to give you
The vertex and it.
and at least one other point. So in order for this to work, right, I'm going to give you a graph, but I'm always going to tell you what the vertex is, right? And at least one other point. Okay. All right. So you're going to write the equation of this one right here. Okay. Notice I have given you the vertex and I've given you 3 other points, right? But really all they have to do is give you the vertex and one other point for this process to work. So here's how it goes, right? So the vertex is at -3, -1, and the other point I chose was -4, 0. So this one right here. Okay, but it would have worked with the other points listed there as well too. Okay, so step number 1, if they give you the vertex, you can't plug the vertex into standard form. You can plug vertex into vertex form. Okay, so if I say the vertex is -3, -1, what here changes? What changes here? I'm handing you the vertex, so what changes? You're overthinking this. Here's the vertex formula. What changes if I tell you this is the vertex? You just plug it in, right? So what's the equation now going to say? You guys are killing me.
3x plus 3 squared minus 1.
Okay.
Whatever he said.
So what are we missing here? Are we done?
How's vertex?
Sure.
Well, we gotta have A.
We got to have A. Does anything up here tell us what A is, other than the fact it's concave up? Therefore, we know it's positive, but what's the A value? And the answer is, I don't know what A value is.
Well, I mean.
So
that's
what's
just-
the pun intended, what's the point of this other point?
Help you find A.
To help you find the A value. Can anybody think that one through?
No, but that looks like.
Guess what f of x really is?
Y.
Guess what x is?
X.
Point has an x and a y.
Oh.
So we're going to take this point and plug in X and Y. So x is now going to be
Negative.
-4 and f of x is going to be 0, and the only thing I'm left with is a, and therefore I can solve it for a. -4 plus 3 squared,
1.
1 times a,
A.
and then move the -1 to that side and you get,
A equals 1.
well, that wasn't very challenging. What do I do with that 1 now?
Plug it back in.
Plug it back in and you're done. Do we actually need this one?
Not really.
Not really, right? So if it was a 1, I would leave it off, right?
So then that's a good one.
Say again?
So we didn't have to actually do all that.
Well, you did because you didn't know A was one until we found out it was one. But to answer your question, yes, we didn't have to do that one, but how were we to know it was one? Just by looking at it. And the answer is you're not gonna be able to tell. All right, we better do one of those together. Oh, by the way, I forget, have you already finished your homework? Does it say put it in standard form, or does it say put it in vertex form? For the ones where they give you the graph? Does it just says write the equation? Yeah. So if it just says write the equation, why would you put it into standard form?
Because we hate ourselves.
Because you're a glut for punishment? By the way, how did I put it in standard form?
With math,
What kind of math did I use?
some good one.
You
I'm gonna throw sharp objects at you.
distributed,
Okay, I'll catch them.
I can't distribute the one because it's squared.
you multiply it.
I
X
just
plus
squared x plus 3. What's x plus 3 squared?
X squared plus.
squared plus
Plus
six
6x.
plus
Subtract 1.
Or plus.
There we go. All right, let's do a few. All right, here we go.
Very smart.
Alright,
Step number 1,
plug in the vertex.
plug in the vertex to the vertex form. Go, Jack.
okay, so. F of X equals. Yeah.
Yeah, so far so
and
good.
then, it's gonna be. I don't remember vertex form.
There you go.
Equals. A times. Yeah. Equals A times. X minus. 1. Plus,
Squared.
or squared, plus -5,
How about -5?
which also works too.
Okay, now what? Jack?
Oh, sorry, you're moving my chair. Now, you were moving, Jace, I felt it. Then you're gonna want to. I mean, that's that, but you gotta find the A, so you're gonna wanna like. Pick, or plug that 2 over.
Tell me what to write.
Okay, so A, or -3 equals A times 2 minus 1 squared minus 5.
Okay.
And
Keep
then
going.
you square the parentheses, which is that one thing. And then you subtract 5 from that one thing.
What do you get?
I want to do math right now in this RDA. Okay, so. 5.
What?
2 minus 1.
Oh, I mean, you can do that. 1 and then square.
Squared is
1.
Okay, now what?
Okay, and then you.
Where did the 1 go?
Move the 1 went nowhere because it's a 1 and it does.
1 times A is A, right? Now what?
Then you add 5 to the other side to get 2. and then
2.
A
What do we do with the
equals
2?
Plug it back in the O.
So final answer?
F of X equals 2X minus.
2
2
times the quantity.
times the quantity of X minus 1
Which is
squared
ideal.
minus 5.
That's it. If they ask you to put this in standard form, then what would you have to do?
Then you like. Do that.
Yes.
Square
Yeah,
I put
You get
the vertex.
X squared minus. I hate factoring.
Double it.
Minus 1X.
2x
2X. Minus 1. Plus 1.
plus 1. And then we got to multiply that answer times 2.
Yes, then you get
Yeah.
2X squared minus, minus 4X plus 2 minus 5.
Which is
The thing.
which is
2x squared minus 4.
Oh, then you can combine the 2 and the -5 to get -3.
and that would be in standard form.
Yeah.
Wes,
What was the 2 positive if it was -5?
how is the 2 positive?
For A.
Because if we add 5 to both sides, you get +2.
How do you get rid of the 5?
I added the 3 to the other side, so I got -2.
Then you get 0 over there.
Mhm.
And you have to move over anyway.
Got it?
Yeah.
Okay. Cool. One more, you got it.
I got it.
Abby? Do you know what we're doing here? I'm gonna hand you the vertex and one other point, you're gonna write the equation of the parabola. Step number 1, if I give you the vertex, we can plug it in the vertex form. So plug the vertex into the vertex form, go.
A times x minus 3 squared plus 0.
plus
Yeah.
plus 0. Okay, cool. And now to find the A value, we simply take the other point. The other point is an X and a Y and throw it in for X and Y. Plug that in, do the math, solve for A, plug that back in, and you're done. Yay. All right, that will do it for today.